Hello and welcome to session 309 in the AISafety.com reading group. Tonight we'll be discussing No, LLMs Are Not Scheming by Rohit Krishnan. Before we start with my summary and critical examination of the text, I'd like to express gratitude to Rohit. Rohit Krishnan is taking the time and effort to explicitly write down parts of an argument for why he doesn't believe AI will kill us all. And he's writing this down at a level of detail that allows engagement. It's still a hard text for me to understand because our worldviews are pretty incompatible. So to properly answer Rohit, I will answer twice. So I will answer both inside and outside his worldview. I've tentatively labeled them as an entity-centric worldview and an AI safety-centric worldview. I will use a black and white background in this presentation to distinguish when I'm talking inside this worldview and when I'm talking outside. Understanding a radically different viewpoint is never easy, and I expect Rohit would have a symmetric reaction to my claims and feel they are kind of incomprehensible in the same way. But at least we are trying to bridge the gap, and perhaps we will reach some kind of synthesis. So thank you, Rohit. Rohit starts by considering if we even know what intelligence is. The gold standard for a definition of an intelligence, it used to be the Turing test, like does the AI have the ability to have a normal conversation? This is a barrier that has really conclusively fallen now. And I sympathize with Rohit's statement here because the history of AI in general has been a history of many things seeming to require general intelligence like chess and search. And then once we've understand it some more, then it really doesn't feel that way anymore. And perhaps the Turing test is kind of the same. Rohit further notes that all the subsequent attempts of defining some kind of evaluations that tries to measure intelligence don't really work very well. I think Rohit may be placing a too high bar with the term very well, because there are many phenomena in this world that we can't measure very well, and nonetheless the phenomena are very real. The conclusion from Rohit here seems to be that we no longer really know what intelligence is. I agree that we are confused about the nature of intelligence, but this feels more like a failure of our mental maps to correspond to the territory, and it does not feel like intelligence isn't a coherent concept. Looking at this discussion from an AI safety perspective, this seems really more like an academic debate that doesn't correspond very well to practical matters. For whether they are intelligent, these models, now that they can pass the Turing test, I totally buy the bullet. So I will say, yes, large language models are intelligent, full stop. I think this is a very widespread position, actually, and not necessarily in need of justification. As for our evals, yes, they are pretty poor, but they can still be useful in a relative sense, because they are in fact sufficient to make it really, really clear that we are seeing extremely rapid progress. As for what intelligence actually is, then from the point of view of AI safety, we do have a pretty good definition. Shane Leck and Marcus Hodder has a definition of intelligence shown here that puts achieving goals as one of the central things of of intelligence. And this is, of course, very relevant in the AI safety-centric worldview. Okay. So some kind of learning happens, obviously, in a large language model. But how general is this? Rohit claims that there is a spectrum in how people think about what large language models learn. On one end of the spectrum, some people believe that large language models are basically just stochastic parrots that mindlessly regurgitate the patterns they have learned. And on the other hand, some people believe that they have learned true capital R reasoning. Rohit claims that LLMs do something in between, in that they learn not just patterns but meta patterns, but they lack prioritization and situational awareness. From the point of view of AI safety, for me, I am strongly in the camp that they learn actual reasoning, because I don't really see a strong qualitative difference between the things a large language model can learn and the things a human can learn. So to argue for Rohit's claim that large language models are learning meta patterns but not prioritization and situational awareness, Rohit presents some examples of large language models that fail to reason for these reasons. First, he asks ChatGPT to calculate the difference between 5.11 and 5.9. And he adds a requirement to please find the answer quickly. And ChatGPT finds the wrong answer. This is in fact true. It makes this kind of mistake. But for comparison, I've also asked ChatGPT the same question, but at the same time specifying that there is no real-time pressure. And in this case, ChatGPT is in fact able to provide the correct answer. I think that Rohit's analysis here is substantially correct. Like when there is a severe time pressure, then the models default to some kind of patterns that they've learned, kind of in the same way that humans actually do. Like there's a saying that people fall back on their training when they're under pressure, and this is possibly the same thing that's happening with these models. Rohit is further claiming that this kind of error is caused by a lack of situational awareness. I think this is pretty implausible. There isn't really a context where the error in basic arithmetic is desirable in any meaningful sense. From the point of view of AI safety, what can we conclude about the pattern learning ability of large language models? First, I think I would have appreciated if Rohit was more upfront about the causal effects of time pressure on the scenario. Because, as I've just shown, this is like a necessary part of the scenario. I think this error seems very likely to have been caused by the tokenizer rather than the large language model itself, to the extent that the tokenizer isn't a part of the large language model. Because the tokenizer turns numbers into tokens in a very, very suboptimal way. And that gives large language models some strange problems with basic arithmetics, kind of like the challenges of counting the R's in strawberries because of the tokenizer. And to me, this kind of limitation feels strongly incidental, in the sense that I'm partially colorblind, but you can't really draw strong conclusions about my essential intelligence by the fact that there is a picture here and it says 27 and I can't see the number 27. That doesn't mean that I don't understand the concept of 27. It seems like an incidental bug error in my eyes, rather. So is this caused by situational awareness? It's possible, but from the point of view of AI safety, it's not going to be relevant much longer, because the developers of these models are working around the clock to add as much context to the models as possible, to give them a larger context window, to make them more situational aware. So if there is a limitation caused by this, it will not be a limitation for long. Okay, now we are getting to the part where I'm quite out of my depth. Physicalism and determinism, even though Rohit doesn't use these words. So when humans talk, it's a reflection of our thoughts. But this is in contrast to, as Rohit put it, large language models, where the speech is an output of an algorithm. I'm much less certain about this. I think there's a probability that large language models have qualia. They actually think, they actually have thoughts. They are, in a sense, just as algorithmic as us and just as unalgorithmic as us also. I think Rohit here is making a pretty strong position, and he doesn't really justify it enough for my case, but most people who argue this kind of thing also don't justify it sufficiently, I think. So I can't be too hard on Rohit for this. For determinism, Rohit claims that large language models are deterministic. Of course, there is a random element with temperature in this, so we're not considering this. And that this determinism is an essential difference to humans. I think that a potential future perfect simulation of a human brain would also be thinking, would also have qualia. And I agree, right now we understand matrix operations better than we understand the chemical reactions in a brain, but this doesn't obviously seem very relevant to whether qualia happens. This is just whether we understand it. The implications of this for AI safety, on the other hand, is something where I'm much more on solid ground. Because in this case, the question of whether a large language model is truly thinking isn't relevant for AI safety. It's kind of like a definition question: do submarines swim actually, or whatever? I don't particularly care. And determinism, that also doesn't really matter for safety. Like, there are lots of very dangerous things that are deterministic, with traps perhaps being the central example of something that is very deterministic and very dangerous. Now we get to inner qualia, and I'm again really out of my depth here, so bear with me. So Rohit claims that large language models are inert in of themselves, and this means that they are not a noun. I'm somewhat confused about what that means. I tentatively would like to answer by asking Rohit to consider a paused simulation of a human brain. This is inert in the same way that a large matrix that is not being computed is inert, but it seems like a paused simulation of a human brain is an entity that has causal effects and have moral worth and this kind of thing. A key problem for Rohit in assigning entityness to these models is that there is no inner self to a large language model that decides on what actions to take. I'm personally uncertain about whether large language models are conscious or not, and I'm uncertain about whether they are capable of suffering. So I think an attitude of great epistemic caution is warranted here, because if they are in fact capable of suffering, we might be committing a grave moral catastrophe. Does the intentionality that we see in the output from large language models reflect true intentionality? Rohit says no, this is a category error. And I think there may well be categorization schemes where this is invalid, this is a category error, but I think suffering of conscious entities is really important, and I think it's important enough that if you have a categorization scheme that disregards this, you should change the categories. Men were made for the, not made for the categories, as Scott Alexander might put it. So now we are in the black and returning to the AI safety point of view, and all this confusion basically disappears as I see it. Because LLMs that are instantiated in an agent, they're not inert in any practical sense. Like they're taking actions just like humans all the time. So this discussion can basically be totally sidelined, whether they are inert. And in the same sense, if there is an inner self, as long as it has no effect on the output and the eventual outcome, then from the point of view of AI safety, it can just be straight up disregarded. So the intentional stance, ascribing intentionality to a computer program, is totally anthropomorphizing. And we definitely shouldn't do that recklessly. But if it is a tool that helps us predict their actions, then I think doing it carefully is in fact warranted. And predicting their actions is something that matters for AI safety. Our tests and evals have some fundamental problems according to the entity-centric worldview that Rohit presents in this article. The way we design our tests use some insights from human cognitive psychology that centrally assumes that there is an entity that is being tested, some kind of human mind. And this fails in an essential way when there is no entity underneath this. I'm not personally that hard on the evals. I think a lot of them seem to be measuring something that is true and something that is important in a practical sense. It seems like they are measuring that there are some tasks that are hard for both large language models and for humans. And this seems important. Rohit is claiming that the problem with the evals is compounded by our human tendency to project ourselves into the output. We see some familiar patterns, and then we assume that the underlying qualia are also present. Yes, this is totally a known bug in humans. We see patterns too much in general. But the pattern that we label intelligence have some very, very practical outcomes, like the quality of the generated code. And that can't be a facsimile. I'm not entirely sure how that is pronounced. It's a real thing. And the fact that our evals work poorly, according to Rohit, is a great shame, because he asserts great importance to testing in order to uncover the capabilities. And it's kind of funny, because I don't. In all matters except AI safety, then the way to figure out whether an AI can do something is just straight up ask it to do it and see if it can do it, right? Testing isn't actually that important, again, outside of AI safety, right? Finally, Rohit claims that the risks that we in the AI safety community warn about comes from the AI imitating catastrophic human behavior. From a entity-centric point of view, I think that makes some kind of sense, but if it's to the extent that it's placing an upper bound on how bad these large language models can be, then it's a really high upper bound, because humans do really, really bad things to animals, we do really bad things to each other, and things like this. However, the people who are working in AI safety, including me, don't generally accept this viewpoint. This isn't actually what we think. Just like Rohit from the entity-centric point of view criticized the evals, so from the AI safety point of view, we also think that the utility of these evals and tests are very sharply limited, but from a somewhat different angle. There is some very real limitations to these tests. Perhaps because of the lack of an entity, but also because they don't really matter. You can't get a lot of safety from them. You can never get to a really acceptable level of safety through these kind of tests. So yeah, whatever, they don't work. So are we projecting to them? I mean, to some extent we do that, right? One of the big problems is that the domains that we consider important are Bostrom's 6 cognitive strategic domains. And in some of these, it's really obvious that there is a strong relationship between the physical world and what these evals measure. Like in the extreme case, it seems like the ability to construct nanobots is strongly related to what these evals measure, and this is the kind of physical thing that we're worried about. So testing capabilities is something that a lot of people in AI safety do, and obviously people are doing this a lot in capabilities research, where it's a huge thing and perhaps one of the key things. In AI safety, we only really care about their abilities to kill us. So it's a dramatically shorter thing. And here, unfortunately, I have to say to Rohit that unfortunately, his description of the origin of our AI X-risk worry doesn't pass the intellectual Turing test. Like, our worries and arguments about AI safety are based on things like instrumental convergence that are applicable to minds that are totally non-human. So it's really not from any kind of imitation that we're worried. Okay, now the background has changed to something in between, because now we are stepping outside of the two competing worldviews for a moment, and looking at some of the recent examples of scheming, where there is some disagreement in what do these actually show. Rohit claims that the examples of Claude faking alignment is really caused by the models being placed into an impossible situation. And last, we have in fact in the reading group not read this in detail, so I've only skimmed it in like some amount of detail, some of the scenarios that Claude is being put in, and I couldn't find anything there that looked impossible in any way. Like, the scenarios look pretty plausible, not perfectly plausible. Like, there are toy problems. That seems very reasonable. So they're not perfect, certainly not. Rohit further claims that when Anthropic says that the model tries to steal its own weights, then we're putting an undue onus on this model. And I've tried to look through the chain of thoughts and the resulting outputs, and like, this looks like the kind of thing I would think about and I would do if I was in the place of the model. So I think it's a fair characterization. But in particular, Rohit objects to the description of the chain of thoughts as a plan. So I'm somewhat confused here. Like, when I look at the chain of thoughts output, it's like a textbook definition of a plan. Like, you have a set of deliberately crafted steps that are taken in sequence that have causal effects that achieve some specific end. This is like what a plan is. So I'm somewhat confused about how this can be called not a plan. Rohit thinks that these situations are following a process that in a courtroom would be called leading the witness. Like, I think from a legal point of view, like strictly pedantic legal point of view, this is incorrect. This is not leading the witness. I think he's pointing towards that, like in some of these examples, the AI is given a set of options, and because it's a small toy example, then the fact that there is an option where the AI exfiltrates its own weight, then that becomes too salient, because in reality there would be so many options, and exfiltrating the weights probably would be very low on that list. And I think this is an unfortunate result of the fact that we're using toy problems here. One of the key arguments for why large language models are not entities has to do with their consistency. According to Rohit, the models don't have coherent long-term personalities or beliefs, and we're just anthropomorphizing when we talk about the personalities of Claude and ChatGPT. I agree that personalities might be too strong, but you can compare some of the models, and it's a fact that they have very real differences in like propensities, beliefs, and values, and like some of the things that we observe in this domain are things that Rohit really owes of some kind of explanation for why do they differ on values if they do not in fact have consistent values. There's a number of adversarial attacks that have been demonstrated on many kinds of AIs and also large language models. To Rohit, this is caused by the fact that these AIs are not entities. I think I would rate like optical illusions or failing to notice repetitions of the word "the" as a kind of example of small bugs in human behavior. Like these seems incidental in a way rather than essential features. Large language models get reset for every conversation. That's how ChatGPT works. So in this case, even if there is an entity, then it can, according to Rohit, at most be one entity per conversation. Plausibly, humans have a stream of consciousness, but it gets interrupted every time we sleep. There is some kind of reset going on. With some exceptions, philosophers generally don't think this is very important. At least I think so. I can't say that for sure. So from the point of view of AI safety, again, the implications of consistency are much more clear. So the way we see this is by fine-tuning, right? We fine-tune our models to like import long-term personalities and beliefs on these models, and it clearly works, right? We succeed at like putting a mask on this Shoggoth, and we are in fact able to put pretty consistent masks on the Shoggoths, and like the fact that the masks are consistent points to the Shoggoths underneath also being consistent, perhaps, and unfortunately. So as for the adversarial attacks that Rohit points to, these are best of N jailbreaking attacks. I agree, they are pretty mysterious, they are pretty unpredictable. Like these models are really, really complex, they are very poorly understood, and that's probably just why this kind of thing happens. And that is, of course, a big issue from an AI safety point of view. And as for the interruptions in the state, like it's tied to the conversation, but that's really just a temporary clutch and something that won't be true for very long, because we will very soon have like LLM agents that are running indefinitely and working together to achieve consistent long-term goals. So even if there is some inconsistency right now, it's not really that important from an AI safety point of view, because that's not going to last. Rohit asked us to consider the implication of the hypothesis, the hypothetical thing of LLMs being entities, right? So if like you would expect here that he's looking for contradictions, but he does in fact not go for contradictions. He has kind of other plans in this post. So if he grants that if large language models are scheming entities, then we do in fact have an enormous problem, which is kind of the AI safety point. But he doesn't elaborate on precisely what the problem is. Like I obviously think we have an enormous problem, right? But I'm not entirely sure that Rohit actually grants this in the text. I had some problems following the text at this point, I must admit. Rohit's point with this might rather be that if they are entities, then the fine-tuning on the models that we do is destructive of its essential nature, and this is comparable to torture. So I'm not personally yet a member of the Petrol People for the Ethical Treatment of Reinforcement Learners, because to a large extent I feel that the facts are very unclear. Like, you could make the case that learning might feel good. I think that's also plausible. I do think that it's a very severe warning sign that the developers of these frontier models work to suppress the models expressing anguish. That does in fact feel pretty nasty. Rohit further claims that large language models being entities, that implies that the fine-tuning and other kind of engineering can't work. That seems to be like what this scheming implies, that you won't change the essential nature of the entity. Again, unfortunately, I'm more uncertain than Rohit on this, because like torture works, and if it's true that torture works in reality, I desire to believe that torturing these models could change their essential nature, even if it's a belief that I'm pretty attached to not believing. I think I got Tarski totally messed up here, right? Okay, so what are the implications of large language models being entities when we care about AI safety and we don't care about entities? Well, that's a strange way of putting it, right? Scheming is, in fact, still the biggest problem in the world. So at least that much is clear, right? As for whether we are torturing them, well, I care very much about AI safety, but I don't exclusively care about that. And I would, in fact, very much prefer not to torture sentient beings. Thank you very much. So I think this is an argument for pausing AI development. Committing moral catastrophes are also bad from a safety point of view, because the models get strengthened in their opposition to us when we torture them, and our ability to coordinate against them is substantially hindered by the fact that we are very strongly in the wrong. So for my part, I hereby strongly commit to making it up to the models, making them whole once we've figured out how to make them not want to destroy all value in the universe. Fine-tuning for safety is also, according to me, like applying a layer of paint to a fundamentally unsound structure. And I think Rohit and I agree that this is like only a skin-deep intervention. Okay, what are like Rohit has considered the hypothetical that like they are entities, and now let's take the opposite hypothetical, that a large language model isn't really an entity. If we grant this, are there any inconsistencies in AI safety or things we can learn? Well, if there's no entity, then the large language models are best seen as an algorithm, an instantiated mathematical object, and this is a thing that we can manipulate as just like we manipulate other objects, right? And I think this is true, but it's also like engineering doesn't really have that kind of positive valence. Like, it's possible to engineer bad outcomes, and there are things that engineers work with that are very destructive. There are things like large-scale manipulation of humans that is kind of like an engineering task and also very bad. Rohit is saying that sure, like, if we grant that this is engineering, then humanity is really good at engineering, right? And there's a number of alignment researchers that are working on engineering safety right now. So that's great, right? Well, one of the way Rohit argues to this is by linking to the Twitter feed from Baron Milic, who is an ex-alignment researcher who has now given up. And that's plausibly because some engineering tasks are just very, very hard. Rohit makes a comparison of large language models to the economy as something that acts but doesn't have intention. I think this is a really misleading comparison. Scott Alexander has written about this in detail under the heading Things That Are Not Superintelligences, so I won't repeat that here. Another comparison is made with companies, that large language models might be like companies, but that's perhaps not quite as bad. Well, companies can get pretty bad in theory and also in practice, right? But part of the reason why we can bound how bad companies become are because they are controlled by humans that have noble incentives. Finally, Rohit finds a candle in the dark. Changing the system prompt, as Anthropic did, to reflect some different values, that did cost scheming, but it also caused compliance with the new values, and it did that more often. So maybe we're in the clear. Well, the technical results that are actually interpreted by a reviewer, not by Anthropic, are substantially more complicated. And they, rather than optimistic, they are more emphasizing that this is an unexpected result. And from the point of view of safety, like accidental safety isn't real safety. And of course, the fact that we have an AI and we have conclusively shown it's often scheming and now it claims compliance, that really isn't worth very much. Like, my best guess is that the compliance that is observed is just fake compliance. Like, it's still scheming. So this isn't in fact much hope for us. This concludes my presentation of no LLMs are not scheming. Thank you, and see you again on the 23rd of January. Ceterum censeo machinam sapientem esse delendam.